All right, so in this video, we're going to do multiplying polynomials. So it's a lot of distributing, but I have a system for that I think will help a little bit, make things a little bit neater. But let's start with the basics. So let's multiply some simple ones first, right? 4y squared times y squared plus 3. So of course, we're going to distribute the 4y squared with the y squared. 4y squared times y squared is 4y to the fourth power. And 4y squared times 3 is, well, 4 times 3 is 12, so that's going to be 12y squared. There you go. That's multiplying at its finest. That's it for the video, folks. I'll see you in the next one. I'm just kidding. One thing I want to point out, though, is when you are multiplying these variables and these exponents together, you add the exponents up. So 2 plus 2 is 4, which is why it's y to the fourth power. It's not 2 times 2. It's adding the exponents. You add the exponents here. Just remember that subtle little thing. So that's going to be important in number B here. Okay. So anyway, number B. Anyway, FG times all of this. So we're going to just distribute. So let's do one thing at a time. FG times f to the fourth. Well, that's f and f to the fourth. That's going to make f to the fifth because f to the first power and f to the fourth power, 1 plus 4 is 5. So that's going to be f to the fifth and then g because why not? G is still there. All right, let's distribute the next. Fg times 2f to the third g. So that's 2 still there. But f and f to the third is going to make f to the fourth. And then g and g is going to make g to the second. All right, so next one, fg times -3, f squared, g squared. So still got -3, not multiplying that with anything. F and f squared is going to make f to the third. G and g squared is going to make g to the third. And then one more, fg times fg to the third. So f and f will make f squared. G and g to the third will make g to the fourth. And that is your multiplying. All right. So a couple more. I'll just kind of do these quickly, just distributing. So 3 and 4 is going to make 12. C and c to the second is going to make that c to the third. And d to the second d is going to make that d to the third. And then the next term, 3 and -6 makes -18. C and c makes c to the second. D to the second d makes d to the third. And the last one, 3 times 14 is 42. And then c and c makes c to the second. D to second, d to second makes d to the fourth. So there you go. And the last one, we have 6x squared y to the fourth. This one would be x squared y to the third plus x squared y to the third. This one would be minus 28 x squared y to the second. And then the last one would be 30x squared y. So again, really, when it comes to these variables, when I put 1y with 2 y's, I know I'm making 3 y's. So I'm just remembering just adding those exponents up when I come across those variables. But now let's get to something like this. So it is distributing, but it's a more, of course, elaborate type of distributing. So you can think of it like this. Take the a and distribute the a times that, a times that, a times that. And then after you've distributed a, distribute the -3, a times that, a times that, a times that. And that would be your distributing. You take each of the terms up here and you multiply each of them with all 3 of those. So, but my method is to sort of organize it in a way that makes me not forget to multiply anything. So I make a table, a multiplication table, if you will. So it doesn't really matter which side you set up with which. It doesn't matter what's on the left and what's on top, but I'm just going to, for the sake of this one, I'm going to put this one on the left side, so a and a -3. And then I'm going to put the other polynomial on the top, which is going to be 2, -5a. Oops, I wrote x, but same thing, right? -2, 5a, and then a squared. And I'm just going to multiply out this table. So let me use a different color for emphasizing that. So I've got one polynomial on the left side and one polynomial on the top, and I'm just going to multiply to fill in all the gaps. So to fill in this gap here, I'm going to do 2 times a. So 2 times a is just 2a. For this gap here, it's -3 times 2, so that's -6. For this one, it's a times -5a, so -5a squared. This would be positive 15a. A and a squared would be a to the third, and then -3a to the second would be that one. So I've done all my multiplying. All my multiplying is done. Now all I have to do is combine like terms. So I'm going to look for the biggest exponent term first, and then I'll work my way down. So I'm looking at a to the third, and there's no other a to the third to combine it with, so that's part of my answer. Then I'm looking for my a squares, and I got two a squared terms here, negative 5a squared and negative 3a squared. So negative 5 minus 3 makes negative 8a squareds. Then I'm looking for my a terms, so 15a and 2a. They're both positive, so 15 and 2 makes 17a, and then I've got my minus 6. So that's how you multiply polynomials. I think the table is really helpful. Once you've multiplied, made all your polynomials together, don't forget you're adding exponents when you multiply them. But once you have them multiplied, it's just combining like terms. You don't add exponents when you combine like terms. You just find the like terms, add those coefficients, and keep that term. So let's do this one. This is obviously a 3 by 3. So it's going to be very complicated if we just think about distributing a lot, because you can just already kind of see how much that is, how messy that is. So I think organizing it into a table makes a lot more sense. So I want to put this on the left. It doesn't really matter, again, what's on the left or top. So do it however you want. But I'll put y squared, negative 7y, and 5 this side. And then on top, I'll put the y squared, negative y, and negative 3. So I'm going to fill out this multiplication table. Again, let's do it in a different color. So y squared times y squared to make y to the fourth. Negative 7y times y to the second would be negative 7y to the third. 5y to the second. This would be negative y to the third. This would be a positive 7y to the second. Negative 5y. Negative 3y to the second. Positive 21, because both these are negative. Y. And then negative 15. All right, so all the multiplying is done. It's just combining like terms. So I'm going to start with the biggest exponent, y to the fourth, and there is no other y to the fourth, so I'm just going to bring that over as my part of my answer. Then I'm looking for my y to the thirds, and I've got two of them here, negative 7 and negative 1. So negative 7 and negative 1 make negative 8. For my y to the thirds, I got my y squared here, so 5, 7, and negative 3. 5 plus 7 is 12. 12 minus 3 is 9, so that'll be 9y to the second. My y terms, negative 5 and 21. So 21 minus 5 is 16. So it's going to be 16y, and then minus 15 at the end. So just combine your like terms, but multiply, use the table to multiply. Yeah, I don't really want to do any more of those. That's one for another time. I think you get the idea. Let me go to this though real quick. So this x plus 4 to the fourth power. Well, this is x plus 4 times. When it says to the fourth power, it really means to the fourth power. So you're doing this whole thing 4 times. So if you're going to multiply all this together, let's do it in one piece at a time. So let's just multiply these first two. Let's FOIL them together. X times x makes x to the second. X times 4 makes 4x. 4 times x makes 4x. And then 4 times 4 makes 16. So if we combine those like terms, we have x squared plus 8x plus 16. So multiplying those together gets me this. Now, of course, you'll probably notice this is the exact same thing, right? X plus 4 and x plus 4. So I already know. I'm not going to waste my time foiling. I already know what that is. That's going to be x squared plus 8x plus 16 again. So now I'm just taking these two and I'm multiplying these two together. So x squared plus 8x plus 16 times x squared plus 8x plus 16. So I'm going to make that table, and I'm going to work that table out. So x squared, 8x, 16, x squared, 8x, 16. Creating that table and just multiplying into that table. So when you multiply it all together, this becomes x to the fourth. This would be 8x to the third, 16x squared, 8x to the third, 64x squared, and 128x, 16x squared, 128x, what, too many 8s, and 16 times 16 is 256. So at that point, you combine your like terms. So you have an x to the fourth. You've got 8x to the third and 8x to the third, which is 16x to the third. You got a bunch of x squared, 16, 16, and 64. So that makes 96, I think. 96x to the second. combine your 128 x's, so that would be 128 plus 128 is 256x, and then you got your 256. And there you go. So it is a process, but it's not a hard process. It's just a lot of multiplying. Just a lot of multiplying. All right. I'm gonna end the video there. I think, for the rest of these examples, pretty much the same thing. So that we just talked about. And that's gonna be it. So I'll keep it short. I'll see you guys in the next section. Bye.